Hi everyone. I'm myself Praveen. Here we have Sri Lakshmi, Santosh, Ravalika, and Bindusri. Today I'm going to talk about the smart irrigation control system. So this document describes the smart irrigation control access system using IoT devices. These IoT devices use it to collect the data on temperature, humidity, soil quality, and the weather conditions. Coming to the project background, the project employs IoT sensors to detect temperature, humidity, soil quality, and weather conditions in the fields. The Coming to the project scope, the scope involved in automating the irrigation of selected areas, detecting the temperature and other conditions is to reduce the manual handling in the agriculture. Coming to the project objectives, collect it collect raw data using the sensors of soil moisturizer, temperature, humidity, and weather. Adjusting the irrigation pumping system based on the soil moisturizer levels. So coming to the deliverables, the project deliverables include the smart irrigation system with IoT sensors and the cost-effective solutions for optimizing the water resistance and automatic sprinklers on the crops depending on the soil moisturizer level to reduce the power consumption and remote monitoring. Coming to the project's milestones, here we have the initiation, design, development, testing, and closure. Coming to the stakeholder analysis, in this we have the project managers, project leaders, laborers, developers, testers, and web designers, etc. Next, my friend will continue.
Yeah, coming to the work breakdown structure WPS, it's like a map that shows all the tasks needed to be completed for the smart irrigation control system project, and also it helps us to understand what needs to be done by step. Here we can see in this chart we can see that there are five phases like initiation, design, development, testing, and closure. In initiation, there are several steps like project planning, requirement analysis, estimation of budget, WBS and Gantt chart, and devising communication plan and risk plan. And coming to design, there are uh, three steps in this like creative prototypes, feedback collection, and designing database. And coming back to the development, coding and programming, web interface and development, and developing sensors and IoT devices. And coming to the testing, application testing, quality assurance testing, performance evaluation, and document test accesses. And coming to the closure and feature update and monitoring app functions. And and coming to the scheduling, it's like the timeline that shows each task then start date and finish date, what is going to do, and what resources they need, like plan to keep everything on track. Here we can see that the test task name and duration, and when it starts and when it finishes, and one of the most important thing is cost, how much the cost that we are giving to the each section. Like initiation, it takes around 7 days with a budget of 17K dollars. And also for the design phase, it takes 5 days with the 23K dollars. For the development and implementation phase, it takes 5 days and with the budget of 30K thousand dollars. And also with the testing, it takes 6 days and also with the $17,000. And also from the coming to the closure and maintenance, it takes 2 days with a budget of 13K dollars. And coming to the cost estimation, this is it helps us to know how much is needed for the project, and it includes for developing the system, buying the equipment, like paying people, testing and training, and many more. Like here we can see that uh, the resource planning, it also this involves figuring out how many resources like people or software or hardware things that we need to be that we need to be installed in our project and needed for the project, and how long for this project till the survival of this project. So the project outline of comes needs to be what needs to be done is when it will be done, and how it will cost, and what resources are required to make it happen. Here we can see here we can see in this chart, like resource, what are the resources that need to be taken, and what type of it, and what materials, and what are the initials that we need to do. And like again, yeah, from here my friend will be continuing from here.
As my friend said, the budget is overall budget is 85,000 K dollars. But by implementing project crashing, it increases by 10%. Because project crashing is a technique used to shorten the project schedule by reducing the duration of critical path activities. It involves adding additional resources such as labor or equipment to complete task faster. The reduction in time is typically by 10%, leading to increased costs due to the extra resource needed. And in this project, it increases around 15,000 K. So overall, the cost estimation is equals to 100K thousand dollars, as you can see here. And coming to the network diagram, this is the overall network diagram for the project. In order to complete this project, it takes 25 days, because it has 5 phases: initial phase, design phase, and development phase, and the testing phase, and closure phase. For initial phase, it takes 7 days. In those 7 days, it involves 3 days of project planning and 1 day of requirement analysis, which is done by team leader and team members. And for estimation of budget, it takes 1 day, and project manager and team members are responsible for it. And for WBS and Jan chart, it takes 1 day. Project manager and team leader take over this. And for devising communication plan A, it also takes 1 day. It is done by team leader and team members. And for coming to the design phase, this is the second phase. It takes 5 days of duration. It involves creating prototypes. It takes 3 days. This is done by designer. And for feedback collection, farmers and team members are responsible. It is done in 1 day. And for designing database, it takes 1 day. It is done by designer and developer. For development and implementation, this is the third phase. For it takes 5 days. In those 5 days, 2 days are for coding and program, and 2 days are for developing sensors and implementation. Network engineer done all the sensors and implementation of sensors. And for web interface in development, it takes 1 day, and it is done by developer and website designer. The testing phase is the fourth phase. It takes 6 days to complete, and in those 6 days, 2 days are for application testing. This is done by project sponsor and tester. And quality analysis is used to do quality assurance testing. And he does his job in 2 days. And for performance evaluation, it takes 1 day. This resources used for this is project manager and project sponsor. For documenting test case, it takes 1 day. Team member and tester is responsible for this. And after all this, the last phase is closure and maintenance. It takes 2 days to complete for closure. And 1 day in that is used for feature updates, and 1 day for monitoring functionalities of irrigation. This is done by team leader and team members and network engineering and network team lead. Thank you. Next, my friend will continue with the risk management.
Let's talk about risk management. Risk management plan for the smart irrigation control system finds and analyzes possible risks and offer mitigation. Important hazards and strategies for reducing them include security risk, technical risk, and regulatory issues. Due to the lack of encryption in IoT devices, which leaves them open to hackers, security risk is extremely high, where impact is 5, likelihood is 5, and score is 25. The mitigation plan involves encrypting data that is stored and putting safety measures into place. Technical risks. There is a medium chance of probable failures or damage to IoT sensors and devices, where impact is 3, likelihood is 4, and score is 12. Updating and maintaining the devices correctly on a regular basis is a part of mitigation. And coming to regulatory issues, as there is a chance that security updates and protocols won't be followed, this poses a low risk, where impact is 3 and likelihood is 3. and score is 6. Following regulatory guidelines is necessary for mitigation. And coming to risk matrix use colors to indicate priority levels and defines possible threats according to their possibility and difficulty. Security risk, as the highest priority, it is shown in red under almost certain and extreme because of its likelihood and significant impact. Coming to technical risk, listed in yellow under moderate and major, this risk is classified as medium priority and indicates a significant but not particularly critical one. Coming to regulatory risk, issues are represented as a lower priority and are highlighted in green under the categories of unlikely and significant, indicating a less demanding but no less significant issue. And by properly allocating resources to address the most common risks, first, this visual representation helps prioritize risk mitigation activities. And next, my friend will continue.
Let's talk about the ethical stuff involved in using smart gadgets for watering plants. These gadgets are like sensors and helpful for, but these some important things we need to think about. Using smart gadgets to water plants is handy, but these are some important things to consider. Sometimes the gadgets act unpredictable, so we can't always rely on them completely. It's crucial to be clear about how they work so people trust them. We need also keep info about crops and farmers safe from pry eyes. This risk for bad people using these gadgets for harm. So we need to strong secure measures, figuring out who owns the data uh, and data and by this gadget is also collected. It's not always easy to afford these gadgets to get all the info we need. To handle these issues, we need clear rules about who owns the data and how to keep it safe. We should train the users, like farmers, on how to use these gadgets securely. And using smart gadgets can also help us watering the plants efficiently. Thank you.